Hello, everyone, and thank you for joining us for today's webinar. This session is part of the Passive House and All Electric Homes Training and Workforce Development Initiative brought to you by the sponsors of MassSave. MassSave is a collaborative of Massachusetts electric and natural gas utilities and energy efficiency service providers, also known as the sponsors, helping residents, businesses, and communities of the Commonwealth save energy and money by improving the energy efficiency of our buildings. As part of this training initiative, the sponsors offer a 50% cost reimbursement for individuals pursuing professional accreditations for either Passive House or Energy Star. Once you have successfully completed your certification course, you can fill out the reimbursement application found on our website and submit it to us for incentive processing. The sponsors of MassSave also offer robust incentives to homeowners, builders, and developers who incorporate energy efficiency upgrades into their design and build high-performance all-electric homes. To qualify, single-family homes or buildings with 1 to 4 units must have heat pumps for space conditioning and electric appliances for water heating, cooking, and clothes drying. Homes can qualify for incentives through one of 3 eligible performance tiers, which include a base tier for homes that exceed the building code, as well as tiers for Energy Star, Next Gen, and Passive House certification. Incentives start at $7,500 a home and also feature innovative market transformation adders, which are designed to encourage participants to pursue additional national certifications for their homes and to incorporate emerging equipment technology to drive higher building performance and enhance occupant comfort. For multifamily buildings, the performance tiers and incentive structure is similar to that of single family, with the biggest difference being that multifamily buildings are allowed to have fossil fuel domestic hot water heating equipment while remaining eligible for incentives. Please note that the program defines low-rise buildings as having 3 stories or less, while high-rise buildings have 4 stories or more, or any multifamily building with centrally metered utilities for tenants. There are some slight differences in the per unit incentives for low-rise versus high-rise buildings, as you'll see in the chart on the screen. And lastly, there are some additional market transformation adders for multifamily buildings, including more options for heat pump water heating equipment, as well as incentives for whole building air infiltration testing. If you have any questions about these incentives, please do not hesitate to reach out to us at the email addresses shown on the slide. And with that, I will turn it over to today's speaker.
How you doing, Keegan? Thanks so much. So good afternoon, everybody. We're going to be talking about the Newton all-electric case study today. Thank you all for joining us. Our panelists today are Nick Falkoff from Auburndale Builders, Richard Lowe from Kaplan Thompson Architects, and Mike Browne from Advanced Building Analysis. These 3 people were the primary builder, architect, and HERS rater for this project, and we definitely thank them all for their time today and for sharing their experiences on this unique build. For the case study today, we're going to go through a little bit of everything from inside to outside and everything in between. We're going to end with the key lessons and takeaways before we segue, like Keegan said, into a brief question and answer period at the end. And just another reminder, there's a Q&A box in GoToMeeting that you can type your questions in, and we'll get to as many as we can at the end. So let's start from the beginning. I'd like to start with Richard. We're going to set the stage a little bit here about the project. So Richard, can you give us a little bit of the background and the genesis for this project?
Yes, thanks, Jamie. The clients came to us largely, I think, because Kaplan Thompson Architects has a lot of experience with passive house projects. Single family, multifamily, and schools. And this site here that they had found had some tremendous opportunities. It's got this fantastic view of the Charles River. The existing house sits on a knoll overlooking the water, and they wanted a low energy, high performance passive house home. So we were delighted to be able to help them with that. The key challenges was that the this view that we can see in the photo there, that's the view looking north. It's a relatively long, thin house and site with a small southern exposure.
Okay. And we can see here in this picture, we have the, let's see if I can get my laser pointer working here. You have the original house. Oh, it's not working, is it? Okay.
Yeah,
You have the original house here, and then there's this little addition that was put on in the 70s back here. Is what
that's correct.
we're looking at. Okay,
And
cool.
the house that's on an unfinished basement, the existing house, the new
Mhm.
program included 2 occupied floors and there's a slight addition in total floor area. The existing house was about 2,200 square feet enclosed
Mm.
space, and the new program increased that to just under 3,000 square feet with the addition of an attached garage as well with interior access. And that was a key part of the program as well, to provide covered access from a 2-car garage on the site. And you'll see with some other photos later how challenging that was.
Okay, great. Thank you. Nick, on this slide, we have some of the key project attributes. What did the homeowners express to you as being most important to them when you set out to start the construction in this project?
So Richard had done a lot of work in pre-construction with the clients on the design, and really did a nice job balancing. We had to keep the existing chimney, the existing structure. We had the views that the clients were trying to emphasize to the river, and then Richard, we tried to balance the performance with the aesthetics. So trying to maximize the views where you wanted them. The trade-offs with how much insulation, how thick the walls could be based on, not trying to lose floor space. So I think Richard did a really nice job balancing the aesthetics and the performance of this. And then the building is super insulated, with the insulation being on the exterior of the building. So that actually doesn't cut into the footprint. So we went outside of the old plane of the sheathing from the old house, and we air sealed from the outside. The building has cold climate air source heat pumps that are super energy efficient. So once we had this great envelope, we could heat it with all electric, which we'll get to in more detail. And then our team has done a number of passive house projects, net zero projects. So we just sort of work with Richard and the clients in terms of phasing the work. You'll see the slides of working around the existing structure. It's a sloped site. We're working on the river. We just had to really break things up into a lot of steps. And then now the clients have moved in, we'll be doing a lot of monitoring of the house. So there's sort of 3 key ways that we monitor our all electric homes. We have number 1, their utility bill, which will tell us how much electricity they're using. Then when they eventually add their solar system, the solar system will give us some feedback on how much energy they're creating. And we're also going to be using a system called Sense, which basically clamps onto the electric meter. It does algorithmic learning to learn how much energy each part of the building, each component of the building is using. So it's a pretty entry-level monitoring system, but between those 3, we'll get a pretty good picture of
Awesome.
how.
All right. Well, speaking of that sloped site, I wanted to just show the audience a little bit of background here. This is what the house looked like a bunch of years ago. Pay attention to that chimney right there, because you'll see it in the next picture. That's what the house looks like today. And so there's the chimney right here. There's the attached garage. It's a more traditional look from the street, but you got a really nice modern masterpiece from the riverside. So Richard, I want to speak a little bit more about this tricky site. You said there was a 20-foot elevation change, and how did the design evolve to respond to what was there already?
Well, that was a big part of it. The main living spaces are on that upper level, which was the main level of the original house. And that's where we have an exterior deck, the best views and so on. The 20 feet drop in the site down to the lowest part of the grade, where there's enough space to put a garage, would make it extremely difficult to provide for an interior access between the garage and the house. That would also put the new structure on the river side of the existing house, which was not possible because of the setbacks given the proximity to the water. There are other setbacks from the road that we need to be mindful of as well. The only place where we could put the garage was underground. alongside the existing basement. So that became the main part of the design, how to accommodate that program. So we now have 2 occupied floors. The living spaces and main bedroom spaces are on the upper floor. Secondary spaces, the mechanical room, the street access, entry door, and the garage are all on the lower floor.
And I'm noticing something very unusual for a high performance building with these elevation drawings. I'm seeing a lot of windows on the east and the north. Can you explain a little bit about that?
That's a very, very good point. Yes, you can see on the east elevation, it's a long, broad face, a lot of glazing, tall windows, sliding doors, lovely, facing east. The south elevation is the one to the top left. That doesn't look like a normal south elevation in a passive house. That was a big part of the challenge. The views are all to the north and to the east. That's where we put the glazing because that met the program and the design requirements for the house. There's a neighboring house to the south of this property. So there are privacy concerns if we put a lot of south-facing glazing there. In addition to that, the property and the neighboring property all have a large number of very tall trees. So even though we might be able to put windows facing south, the shading from the existing trees would limit any solar gain we have there.
Got it. All right, well, that certainly helps explain that. On these 2 slides, I'm just going to go through these a little bit from a high level, no pun intended, but these are the top-down views of the house. And you can see in the purple, that's the original home. And this is the lower level here. And you can see anything outlined in green is what was expanded. So you can see the lower floor and the upper floor here. So as Richard said, there's most of the living space on the upper floors at this point.
And because we removed the 1970s addition, that's sort of outlined in red, where we placed the exterior deck, the overall footprint of the house towards the water didn't change. We just changed what we put there. So the new addition, the garage at the lower floor and spaces on the upper floor, they were added away from the river. So we took off some space and we added some space.
Great. Well, thank you very much for that overview. I would love to talk about building envelope, the insulation, the air sealing strategies used for this house. I'm going to throw this over to Nick. Would you care to talk about the way this home was insulated and outsulated?
Yeah, so has the echo stopped now? I turned down my audio.
Yep, sounds good now.
Okay, so the way we start with the air sealing and insulation of this building is really at the sub slab. So starting at the basement, we work our way up. So the bottom of the slide, we have 9 inches of reclaimed EPS. So we work with a company called Boston Green Insulation Group, and they take a lot of insulation off commercial buildings, and we reuse that in our building. So so we have a 9-inch R36 slab over that is covered with stego. We'll show you slides of that. And that stego is the beginning of our air barrier. And then when we get to our foundation walls, we've used exterior EPS, and we've got our air barrier that picks up at the beginning of the bottom of the walls. We're taping to our concrete, and we're going up with a zip plywood. And we have 2x6 framing on this job with dense packed cellulose. And then outside of our dense packed cellulose walls, we're using 2 inches of reclaimed polyiso and 2-inch zip R, where we're basically getting the polyiso is already fastened to the plywood. It saves a step going around the house. Framers are pretty familiar with it. And then we just, we tape all that. So that's our exterior air barrier. And then on the roof, we did the same thing, except we have 2x12 rafters. We're dense packing those with cellulose. And then we're going to show you some slides of the reclaimed polyiso, 2 inches, and then 2 inches of zip R on the top, which gives us a total of R64.
And very important, because this house was targeting level 2 for the all electric offer. this is a continuous layer of insulation across the entire circle of the house, which is fantastic. So what about the air sealing? I know you had a target at the onset. What was the strategy with air sealing for this house, Nick?
So because this was a retrofit and we weren't sure exactly how tight we were going to be able to get it, we had our goal initially set out as a 1 air change per hour or less. We actually exceeded that goal. But as we were taking apart the structure, and you'll see slides working under the old structure, you know, we really weren't sure, like, how are we going to air seal around like all the old joists or the old rafters. And we gradually took more and more of the building apart. So we did multiple blower door tests. So we typically do is we put up our box. Some people call this the Duplo method. Some people call it the Steve Basic method. They debate who came up with it. But after the initial layer of sheathing goes up and is taped, we're going to test the building then. And then we have Jason Taylor come out and he'll run a test for us. And then once we cut our windows in, we're going to test again. And the importance of testing multiple times is you want to catch your leaks as you're going. You don't want to wait till the end and say, oh boy, we missed a leak, and you don't know, is it your sheathing? Is it your windows? Is it a soffit? And so even after multiple tests, having the windows in and then testing again after the insulation was in, we still weren't hitting our number. And when we so we decided to use aero barrier on this project after we drywalled, after board and plaster, because we really wanted to exceed our number, and we were having trouble chasing small leaks. So what we've run into on previous retrofits is once you get down to a certain level of air tightness, it's kind of hard to pick up, you know, 3 or 5 CFM leaks with an infrared camera or with a fog machine. And so what the aero barrier allows us to do is to really guarantee we're going to hit our air tightness number, and without a ton of labor. So what you're going to see when we used aero barrier is that in an hour and a half, they were able to, you know, tighten this building up, seal up the stuff we would have been chasing, you know, manually for probably a week with carpenters. So lessons learned from aero barrier. Number one, you definitely want to do it before your trim goes in your flooring. We put it in, you know, because what happens is as they pressurize the building with the aero barrier, once the caulking, once they take the pressure off, it all drops to the floor. So if you're going to use this on a retrofit, you really want the clients to be completely moved out, or if you're doing it on a new house, you want to do it before you put in all your baseboards and your sills and your trim details.
That's a good call.
Yeah. And we had Jason Taylor out to do a test and chase any leaks. You don't really want to use the aero barrier for chasing big leaks because it'll just takes longer, it just runs longer, costs more. So we were very happy with it, and I think we're going to use it again. We waited a few years to use it, but to see what other people were writing about it and if they were having success. So overall, very happy.
Well, I think the next slide here shows that it was very much a success. We have achieved a 302 CFM 50, which is a 0.57 ACH 50, 0.043 CFM 50 per square foot, and that was taken down from about 600 CFM to about the 370 before just for the process of the aero barrier, which took, as you can see in this graph, about an hour and a half, 45 minutes to do for the whole thing, which is fantastic. Mike, I want to ask you real quick, for context purposes, what does a traditional standard house have to be built to for air change per hour? Just where does this one fall in relation to that?
Sure. Current code is 3 air changes per hour at 50 pascals.
Oh, wow.
Here we're at 0.57, so this is 5 times tighter than the current code would require for the air tightness test. It's also just beneath the 0.6 ACH 50 that Passive House used to use as their limit. Passive House has moved to a number which is now normalized by surface area, so that's why you see the last metric there. And the new limit for Passive House is actually 0.06, and this came in at 0.043. So this was a fantastic result, and it's really obvious to me that there was a lot of attention put into the air sealing throughout the process. You know, and it just incredibly impressive that it got even tighter after the aero barrier with remaining things that Nick must have still found after the aero barrier.
We'll talk a little bit later about the diligent construction. So speaking of the construction phase, I would love to show the audience a little bit more about, you know, what this house looked like when it was in the different stages here. So Richard, can you tell me a little bit what we're seeing in this photo here?
Yeah, I love this photo. It's a great drone photo, but the existing house, the original house is obvious. You can see the hipped roof there, the stone chimney, the road beyond, and the new foundation at the lower level. The garage with its full height concrete retaining wall on the left, then the wood framing, new framing, you can see that's visible. The existing framing on the upper floor, you can see that as well.
There's a
Yeah,
pretty cool follow-up shot here. Ready? Check this out.
yeah,
This is the house on piers, basically. Yeah.
yeah, that's right. That's the existing house with the cladding and the windows removed. Everything that we didn't want to keep, that's gone. What's left?
So I know that there's a lot to talk about with the foundation here. Nick, can you speak a little bit to the underpinnings and what are we looking at here?
Yeah, so as you saw in the previous slide, we kind of had to pick up the house and brace it from below. And one of the historic characteristics that the city wanted to preserve, the owners wanted to preserve, was this fieldstone foundation, fieldstone chimney. And so this chimney, we actually ended up having to underpin underneath of it and to brace it. The walls around it were really not doing well. And so you can see in this photo that we sort of poured a new wall leading into that chimney to brace off of and to stabilize that. So we had to do the, Bob Franchi, who did the site work here, he did about 8 different concrete pours. So we'd brace, we'd form, and then they'd pour, then we'd brace and form and pour. And so we really couldn't do this all in like 3 or 4 pours like a typical project. We had to sort of sequence it, and it was a process, but we were able to preserve the chimney, and it's in great shape and no cracks, and it's in better shape than it was. So yeah, it was
and the aero barrier sealed right around it, which was great.
Yeah.
All right.
Makes it look like it was always there.
Exactly. So we have a picture coming up here of the detailing at the wall base at the window. So Nick or Richard, would either one of you like to comment on this detailing?
Well, I'll jump in and talk first about the window location and the framing and the outsulation. That's all shown in this detail. And the windows, we'll talk about them in a bit more detail later. But these are triple glazed units. Some of the larger windows are quite heavy. Locating them in the line of the existing framing means that they have support. So that makes a lot of sense. And then we've got the issue of the continuous insulation on the outside. So our windows appear in the middle of the finished wall, which gives it a contemporary look, deep shadow line, which is nice.
And this particular image doesn't show all the way down to the subfloor, correct?
Not down to the footing. That's the concrete slab on the lower floor.
Perfect.
Yeah,
and
there's the 9 inches of reclaimed insulation. There's a narrow thermal break between the slab and the edge, and we've got exterior foundation wall insulation down to the footings.
Great. So this is the stego stuff that you were talking about, Nick. Can you describe that a little bit more?
Yeah, so typically in construction, you'll see like a 5 mil or 6 mil polyethylene sheeting people put down, they pour their concrete on top of it. And a lot of times too, the site contractors like to go through and punch holes in the poly so that the water from the concrete will drain through. So in this site, what you're seeing is you're seeing the EPS, and then there's some thickened footings, thickened slabs in the middle, that recess there in the floor. That's where we're putting our interior bearing walls. We like the stego because it's really durable. So like a 15 mil. It's a little hard to form your corners, but once you get used to it, it's and you just have to remind the site guys that when the concrete is wet, they can't punch holes because that's our air barrier below our slab. And then it's also key that wherever that slab meets the wall, we've got to have a an 1.5 inch or minimum thermal break. Basically, we don't want the outside wall touching our inside slab. We want that totally thermally broken, because otherwise that slab will get cold around the edges, and it's a place where moisture can condense. So yeah, we bring that stego up the walls, and then we tape that to our walls, and then the drywall going over that and the trim will seal that to the wall.
That's really neat. Cool. I'm glad you were able to share this image with us. That's really cool. And one of the things that we've been talking about a lot is this reclaimed insulation. I can see some of it up here. How does that affect the project, and why did you choose to go that way?
So we try to work with materials that most framers are already familiar with, right? So if you're new to this, you know, most framers are used to seeing plywood, zip plywood. And if you give them a plywood with an insulation that's already attached to it, which is the zip R, it's not like that, it's not that complicated for them. It's just a little different. And so we like the reclaim. So what you see in this picture is you see the green R zip going over. That's our second layer of sheathing. So it's not the 5/8, that's the 1/2 inch. The primary is the red, that's the 5/8 you see in the back of the house, and then you see it transition to the black. The black is the reclaimed foam. So we're trying to move away from foam when possible, but if we are going to use it, we try to use reclaimed. And so what you're seeing is the initial sheathing, which was red 5/8, then you're seeing the polyiso that's reclaimed black, and then you're seeing the green second layer, because we don't need 5/8 for the second layer.
Another thing, Nick, that is visible in the photo is that red layer of sheathing has the black tape on the joints. That's the air barrier.
Yeah, and we're protecting our air barrier too. So it's something we like about exterior air barriers is, you know, we're taping it, rolling it, and then we're covering that over, so our air barrier is protected from the exterior by that secondary layer of sheathing.
Are there any issues or concerns with using zip R on a roof like this, or is that tape really kind of solve that for you?
Well, because the structural engineers want to see their 5/8 for shear on their roofs. So long as you're using 5/8 for your first layer, they're fine with it. If you're trying to use the zip R without that first layer, you have to do, there's different shear details you have to do, and we just stay away from it because it gets overly complicated. Because the further you get your sheathing from your frame, the less strength it has for a shear value. So we don't. There's ways to do it. We just stay away from it. It's too complicated.
Okay. And the one last thing I want to point out here, I've heard that using reclaimed foam especially can help with the overall fit of the foam, because sometimes brand new foam can condense or shrink over time, and this has already done that.
Yeah, so like we're trying to move away from foam in general. Like I use closed cell I live in an old house. I've got fieldstone walls. I sprayed those with closed cell 10 years ago. That closed cell is lifted an inch off the floor, and there's hollow spots behind the walls. So as foam cures over time, a lot of it off gases and it shrinks. And so what you find with old foam when they take apart old roofs is that if you have an 8-foot sheet and it shrunk 1/4 of an inch, and every sheet shrunk 1/4 of an inch, you would have these 1/2 inch gaps between your sheets. So reclaimed foam, it's already off gassed, it's already shrunk. So we put it on, we're not worried about it shrinking over time. So we call it like pre-shrunk jeans, pre-shrunk foam. And
so the next couple of slides, we're going to talk just a little bit about the roof edge. I do want to point out we're about halfway into this presentation right now, so I want to make sure we're keeping up on time. But just on this slide, so we have the original roof detail right here, and you can kind of see it in the picture. What I'm actually going to focus on is the next picture, which shows what you ended up adapting to. So can you talk just a little bit about the continuous continuous insulation barrier and air barrier at the eaves? I'll throw it to Nick.
Sure. So Richard had an initial design, if you go back to the previous slide, Jamie, and you saw that the continuous insulation overhung the eaves, but it's not really doing us any good. We'd actually had this detail in another project. That exterior insulation out over the eaves isn't really serving any insulated purpose. And so what we did is we said, well, hey, and we worked with Richard, hey, can we just frame that out? You know, we pre-frame those soffits on the ground and then just bolt them on. And what this allows us to do is to have the structure of the soffit tied directly to the plywood that's going up. So it gives us it ties that soffit back to the main roof. So the plywood is continuous on our overhangs, and it reduces the amount of foam we needed on the job.
And this was the same detail, whether it was an attic, flat, or a cathedral, correct?
Correct, yeah.
Very good, very good. Well, let's lead us into another topic here. Let's talk about windows for a couple of minutes. So we know that these are some pretty hefty windows based on this picture. So Nick, can you tell us a little bit about what was selected and what makes them different from a traditional window?
Sure. So we went with European Architectural Solutions, EAS. We've done a lot of work with them. These are Schuco triple glazed UPVC windows. We've worked with them a bunch. They're very heavy, so you can see these units. These are big units. Those panels break down into, we probably need 4 people to move each one. They're really easy to operate. The hardware on them is great. So you can see these huge sliders that face the river, but you can move them with one hand. Richard really wanted very clean lines on the inside, so a lot of the detailing is to try to minimize the lines to emphasize the view. But these windows, they don't have nailing fins, which you'll see on some other slides. These have clips that we install from the inside, and we're setting that window into the window buck, and we're doing some taping. We're taping the windows and then the sills before we set it in. So we use the zip stretch tape at our sills. We set that on top of a clapboard, and it's a little bit different installation. You need to have more people to move these windows because they're heavier, so it makes some of the cost. But one of the big differences I tell people is you can put your hand on the glass of these triple glazed windows in the middle of the winter, and it doesn't feel cold. And people are so used to these big expanses of glass feeling cold or drafty. And if you tape them and there's no draft and it's triple insulated, it's very comfortable right next to the glazing. So most people are not used to that. Richard, sorry, I'll turn it back to you.
Yeah, the whole subject of windows was a long discussion with the clients, and we reviewed a number of options with them through EAS, who are great. The windows that we ended up with, they're these, you can see the profile there. The other options we looked at, there were wood windows, aluminum clad windows, lovely finishes. They're more expensive. We ended up with this version of the windows, which seemed like it was an excellent balance between performance and cost.
Great. And I know, Mike, you wanted to talk a little bit about, just real quick here, about the glazing values here. So you were talking to me earlier today about European windows versus American windows and the sticker here. What can you talk about with that?
Sure. What we're looking at here is one of the 2 labels I think that actually showed up that show us the numbers that we use in HERS ratings. We use an overall U factor that combines the frame and the glazing, and an overall solar heat gain coefficient that combines the opaque and the glazing areas. So that's what goes into a HERS rating. It's a little different than what goes into a passive house rating. In a passive house rating, the passive house consultant is able to enter a U value of glass and a U value of the frame and the relative areas of the glazing in the frame. And under the hood in the passive house software, it will calculate this overall number. You can go through the software and pick it out for each window, but in this project there were between 40 and 50 windows, and it's actually quite a bit of work to calculate this for each window. If we were really trying to get the very best result, though, we would do that, because these windows varied a lot in their size, and we could have gotten a little bit better modeled performance by being really particular about calculating an overall U and an overall solar heat gain for each window. Instead of doing that extra work that would take, in this case, we did just use one of the most conservative numbers for any of them. And you can see that this one is for a patio door, relatively big opening. Right. This is one of the higher numbers. There are other windows might be better than this. Good. This actually has a pretty big frame area relative to glazing area, being a door rather than a window.
Well, appreciate the insights on that, Mike. Want to talk a little bit about mechanical systems in this house. So we're going to talk a little bit about what was selected. So Nick, you want to speak a little bit, just real quick, about the process for selecting the equipment?
Yeah, so Richard's team had done an energy model, and we made some assumptions about what we thought our air tightness would be and what the envelope would be, and things kind of changed as we took apart the building and the project sort of evolved. But anyway, we approached this, we were going to be going all electric. So these are all Mitsubishi cold climate air source heat pumps. So we have 2 outdoor condensers, you can see in the photo there. and we have a heat pump, hot water heater. So basically all electric heating and cooling. We've got 2 Renew Air ERVs. A new resource that's come out, and there's a link here to this NEAP, which for sizing your cold climate air source heat pumps. We ended up making this building tighter than we initially thought. We probably could have downsized these units to smaller units, but you know, our HVAC contractor was a little conservative. But this NEAP resource is pretty new. Mike gave us this, and I think this is a good way to cross-reference. So if you're not sure if you've got it sized right, you can check that out.
Yep. Our advice is always to use your HERS rater's energy load, your heating load and cooling load calculated with the insulation levels and air tightness that you're actually building with, and the window values for that matter. And you'll very likely end up with smaller equipment than you might otherwise need, and more properly sized equipment. It's so important to size, particularly cold climate air source heat pumps properly so that they meet the load at the coldest temperature, but they don't short cycle a lot either.
Right. And I will just remind the audience, anybody who's doing the Mass Save all electric offer, there is a heat pump qualified product list that Mass Save operates, which is related to, but not exactly the same as the NEAP list. So just make sure you're double checking that if you're selecting equipment.
I think the NEAP list just has the best data to describe.
Yeah, it does have great data, great sizing data, stuff like that for sure. So just real quick overview, we have the water heater. Like we said, it's an 80-gallon heat pump water heater. You have an ERV on the lower floor, 1 Mitsubishi condenser with 2 wall mounts and a floor mount, which is this one here. On the upper level, you have another larger ERV. You have 2 condensers with some ducted and ductless mini splits. Very important with this house. We're going to talk right now about ventilation. So we talked about the ERVs. I would love to talk a little bit about how a ducted ERV helps maintain the balance of ventilation in the home, keeping in mind that we have about a minute to talk about this. Mike, I'll throw it to you.
Yeah, sure. Air quality is so important in a tight building. We need to have healthy changes of air for the people living inside. So the ventilation rates are going to depend upon how many people are expected to be living there and the floor area, which is a proxy for how many people might be inside as well. But it's really important to distribute this air to all parts of the home where people are going to be spending time. And this is really nicely done in this case with 2 different ERVs, one from an attic space and another from a mechanical room on the lower level. We go through and we actually verify the flow rates after they've been set up and balanced by the installers. And this was working very well. This type of ventilation will be exhausting pollutants and also putting fresh air into all these living spaces.
Yeah, so the focus on indoor air quality is very strong with a house like this. I appreciate that for sure. Mike, I'm going to put you on the spot again real quick. Talk a little bit more about the role of the HERS rater in general, and then in this project. We know from talking to you before, you kind of came in towards the tail end of this project as opposed to when a HERS rater might get involved typically. So tell me a little bit about just a real quick overview about how the difference in this project, what changed?
Happy to talk about it. So for typical new construction, HERS raters are involved from the time of design through to occupancy. And the energy modeling that we do based upon the design is used to pull a permit. We can help influence the design at this time. We can help people optimize their investment in all the different types of energy efficient features that go into a home, optimizing for whatever performance goals they may have. And then throughout construction, we are there to try to make sure things happen as planned. So rough inspections are important for looking at the insulation and making sure it's working together with air sealing details, and looking ahead to ventilation and plumbing concerns. And the final inspections will have final testing of air tightness and duct leakage and ventilation airflows and verification of all the installed features, being mechanicals, appliances, lighting, and renewables if there are any. That all goes into a final updated energy model, which is used to get an occupancy permit. On this particular project, being a renovation and addition, they did not require our services to pull a permit. And they already had some excellent expertise from their architect and their builder. So they weren't really looking for the design guidance that we often are providing. And they actually were even testing themselves. So Nick has a lot of great experience with all of this. So he didn't really need my services early on. But partway through, they realized they really ought to be taking the advantage of the Mass Save incentives. So I got pulled in late in the game to make sure they could qualify for the Mass Save incentives.
Perfect.
One thing I just want to add to that is I actually, even though I have a lot of experience and Richard has experience, I would have liked to have Mike involved earlier because there's so much knowledge that the HERS raters have in the specialty that they're a real resource. So I have a lot of experience and I still am picking up things from Mike every time we talk. So I think thinking about your HERS rater as somebody who's really just focused on this is like, you know, builders should really lean on their HERS raters to pick up these things. So, you know, it can be something where even if you don't need it, I think for renovations, I would really like to have a HERS rater on every renovation now because there's so many new programs and there's so many details to keep in mind.
Well, I will say that the results are pretty strong for this house. Even though you got involved late and we couldn't do some insulation inspections and stuff like that, there's a lot of awkward glazing potentially and all that kind of stuff. We still achieved a HERS 39 with this house, almost a 52% savings over the Mass Save baseline for new construction. That's really impressive. And hot off the presses, we learned after we published this today, if you model it with the solar, it goes down to about a HERS 15. So that's pretty impressive as well. So Richard, I just want to ask you real quick. You mentioned earlier that you were targeting passive house. Was there a reason that you didn't end up certifying this one?
Well, yes. So we saw at the start the orientation of the site, the house, and the surrounding trees. We knew that we wanted to have relatively large glazing areas facing east and north, and that really put us on the back foot in terms of chasing passive house. At the same time, the clients still wanted a high performance home with a low energy, long-term result for the house.
Perfect. Well, I want to show some pictures of what this looks like. You can't just talk about a house without showing the nice work that these guys did. So we have the view from the living room here, the 12-foot ceilings, the big skylight above the stairwell, which is up here. You got a view from the kitchen, which shares the river views. You got some really cool indirect cove lighting in the kitchen and in some of the other rooms. It's an all-electric home, as we mentioned, so we have all-electric induction range for all the cooking needs in the house. The homeowner said that they were skeptical of going to an induction range to start, but they quickly got used to it, and they said it's actually way better than any gas stove they've ever used. So I'm very happy to hear that from them as well. And then one more view here from the dining room over to the Charles River. I want to get to, I know we're running a little tight on time, but I want to get to the one question I know that most people in the audience are probably thinking about. How much does this cost? So let's take a couple minutes here. One of the main takeaways from the first webinar that we had on the Acton house was that there was a lot of questions about, you know, is a passive house or is a all electric home going to cost, you know, break the bank when it comes to constructing it. We know this was a custom build. We know it was done pretty much all during COVID, but Nick, can you speak a little bit to these first numbers here and you know, how did this compare to a more, I guess, traditional custom build, if you will?
Yeah, so I sort of tried to break out, you know, if we had just built this to the code, what's different about this house and what does that element cost? So every custom house, people spend all sorts of different things on customizing features that don't have anything to do with code versus high performance. So looking at this, it was about a 10% budget increase, and about half of that increase was really in all the exterior insulation you saw. So after the framers put up the initial frame, they had to go back around, put the polyiso, and then go around again and put the zip R, right? And so you know, from the material for that and the labor for that on the walls and on the roof was really the biggest part of that. That's about 50% of that 10% increase. Looking at the HVAC systems, we had 2 ERVs. You know, some people, you probably by code could have gone away with 1, but we wanted more control over the ventilation and where we were getting it. And so I think we had about 10% HVAC costs, you know, and then the windows and doors, they're being triple glazed. They cost about 30% more than like a Marvin or a Pella, and they're a little heavier and harder to install. So, you know, so part of that cost increase was driven by the windows and doors. But it also allows us like you can't, the Americans can't really manufacturers can't make windows like these. So it's not really apples to apples, I always tell people. And then another big part of what drives the cost is the coordination. So there's a lot of details. Our team's pretty experienced with high performance building, and Richard's really experienced, but you know, there's still a lot of coordination of these details to make it like when there's no real trim on the inside of this house around those windows. So getting the lines right, making sure that you know, everything's going to work, you know, that it adds a fair amount to your project coordination budget. So, you know, if you take that over the lifetime of a building, you could say, well, you know, if we put solar on this building, we don't have a utility bill or minimal for the life of the building, does that pay back? And, you know, I think every project is a little bit different. But, you know, I think that gives you a general sense. If you look at the rest of the features of the house, it's not really related to that drove the cost. Working under an old building and pouring 8 times versus 4, those things drove costs in this project, but they had nothing to do with the energy component of it.
And like you said, there's the trade-off of not only lower costs operationally over the lifetime of this house, but we also just talked about the health of the home and the occupants inside, and all of these so-called upgrades really do pay for themselves in many different ways. So that's a great takedown. I appreciate that.
That's right, Jamie. Yeah, it's an intangible thing, but along with the, you know, the some additional cost, but it's hard to quantify how much of the extra comfort, the improved comfort within the house, how much is that worth? For how long?
The sound benefit, I think, is so massive. In today's day and age, with all sorts of online meetings, you would think that in and of itself might be a huge value.
Absolutely. I don't know if you guys heard the Black Hawk going over a few minutes ago. So yeah, I know what the sound deadening can do for a house. We're going to talk real quick about best practices, and then the next slide we're going to talk about lessons learned. So best practices to reduce costs for a high performance building. You know, this one obviously was a little different because it was a retrofit almost. What do you think? What are the biggest things, the best practices for reducing costs overall? Involving the refrigerator early, you said.
Yeah, this project was unique because of its site, and obviously we did such a major change to the interior and exterior of the building. A way to minimize costs is just focus on the shell upgrades and equipment upgrades, but don't move the windows and doors around. Don't dig out an underground double garage. Don't turn the building around to, you know, from facing the street to facing the water. That would be a good start.
So as far as lessons learned from this particular project, you definitely summarized quite a few things already during this presentation, but if anybody else is considering a project sort of like this, where they're going to take an older home and, you know, bring it up to really, really high standards with almost passive house design thresholds and things like that, what do you think? What suggestions would you guys have for starting that process, and what are the best practices you can talk about with that? You want to start with you, Nick?
Yeah, I mean, I think something we really try to emphasize is, you know, upfront, a lot of people, if they haven't done high performance before, their first time through, you know, I always tell people you want to have at least one person on the team that has experience. So whether that's your HERS rater or your architect or the builder or even the client, right? Somebody on the team who's in the core of the team has to have experience with this, so they know what dials they can dial in and what impacts. So if you're going to do this for the first time, try to make sure you have somebody. And sometimes you just have to bring in a consultant. Like you might not need Mike Browne because it's a renovation, but you might want to hire Mike Browne just because he's got experience and can guide people on things. So I think one of the keys is experience and then talking through the options. So when we evaluate window options, going with people who have experience. And if you haven't got experience, you can hire a consultant to help you. And it's money well spent. You're really sort of getting your education in high performance. And then once you have that team, having regular check-ins. So Richard and I, we talked every week. We do a call, and we would send out a list of questions we had in advance so he could prepare. So we call that an RFI log. We talk a lot about what questions we have, and then sending them out in advance so he can prepare. And it's okay. Richard would never, he would answer any question we had, and if we had a suggestion, he was open to discussing it. So I think having that trust with the team and just making sure that you're staying ahead, say we're really not sure how this detail is going to work. Can we focus in on this and spend some extra time? And I think that's the key to delivering these high performance projects, is having team trust and excellent communication throughout the whole way.
Yeah, I think I'd agree with you there, Nick. I'd emphasize that particularly with this project, we started construction just as the pandemic appeared, and knowing that we had an experienced team made a big difference. Getting together for site visits, was a challenge. Being able to work remotely, being able to be flexible, and trust the other people on the team.
I think one of the things you both have talked about is the sharing of information among the team and the project coordination among the trades and about everybody on the site. It was definitely a very important thing from what I'm hearing. What do you think the biggest takeaway was from this project?
Richard, do you want to take that one?
Biggest takeaway, I'd have to say it's getting back to the team again. The team's led by the client who, drove the high performance, the attention on passive house detailing, and really made sure that it happened. It's hard for clients. This is only one part of their life, and often it's the one and only time that they engage in a project of this size and complexity. So getting that team in place and then trusting them to be able to do what they can do.
Great. I want to share one more slide here, just talking about the outcomes. You said you had weekly Zoom calls, the request for information spreadsheet that you shared with everybody. I think this is a very good takeaway for any builder and architect HRSA raters out there that are listening today. So yeah, we have a couple questions from the audience. One was a larger 400 amp panel required for this house with all the electrification?
No, so this is just a 200 amp service. There's not a lot of, so when you get your air tightness down, you've got the superinsulated envelope, your loads are actually pretty low. So this is a 200 amp service, with plenty of room for future car chargers and for, so no 400 amp service needed.
Fantastic. And then somebody asked about the cooling effect of the heat pump water heater, and I know Mike had talked about some sounds in the house, and I know that there's potentially people that are concerned that if they put a heat pump water heater in, it's going to be loud and it's going to make the rooms cold. Mike, you want to speak to that real quick?
Sure, some best practices there. Heat pumps do need to take some heat out of the air. It's not a lot, and the more air you give it, the less it changes the temperature. So it's actually not a good idea to put it in a very small closet without a little bit of air, where it would change the temperature more significantly. Better to give it a lot of air to work off of. It is good to put it in a place with high thermal mass, Foundations are good, slabs are good. Those things change temperature slowly and provide something of a reserve. Sounds can be mitigated by where you put it again, but also just keeping it clean. We see noisy heat pumps almost invariably have gotten dirty during installation and construction. So keep them super clean throughout construction, and they will be a lot quieter when they finally run. One last thought is if you want to get really nerdy about it all, you can take the cooler air from the heat pump, which is going to be cooler, drier air, and put it where that's useful. You might put cooler air, duct it from, and some of the heat pumps actually have duct takeoffs. You can duct it. You could duct it behind a refrigerator and improve the performance of the refrigerator because you're cooling off the coils behind the refrigerator. So if you get creative with this, there's lots of things you could do.
Awesome. All right. Well, we're just about at time here. So thank you all for your contributions to this and for participating today. Is there any last statements from the three of you that you'd like to share with the audience before we get off?
If you're going to do a project like this and you should join either NESI or contact Passive House Massachusetts, because there's whole networks of people that are happy to help you learn the stuff, and that's how I've learned it over the years. So there's a lot of groups out there to help people learn how to do these things. You don't have to learn we don't have time to learn just from our mistakes, right? We have to learn from other people's mistakes. And so NESI and Passive House Mass are both great places to go to learn some of that.
And it's the nature of a HERS rater's role to see lots of mistakes. We're always troubleshooting.
So we're always learning. We're always learning.
Talk to your HERS raters, and they will share with you, I'm sure, all of their experience. And we see lots of different projects, so we see lots of great ideas, and I think we're all happy to share what we learn along the way.
Any closing thought from you, Richard?
Oh, thank you very much for inviting us all to talk and giving us an opportunity to talk about such a fun project and a great project.
Well, thank you all for being here, and yeah, we'll have the recording available shortly. There'll be a link sent out, and we'll get you the slide deck, and there will be a published case study on this house from MassSave as well in the coming weeks. So stay tuned for that as well. And thank you all for your time today. Appreciate you all tuning in. Have a great day.
Thanks, Jamie.
Yes.